Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this simple math problem that many people actually get wrong. So right here we have 7 minus 7 divided by 7 minus 7. And to solve this problem, we need to use order of operations, also known as PEMDAS. P-E-M-D-A-S. Now the parentheses, the P, this stands for parentheses, the E, this stands for exponents, the M, this stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. And this is the order which you want to solve a mathematical problem. You first start with whatever is in the parentheses, then you go to exponents, then you go to multiplication, then you go to division, then you go to addition, then you go to subtraction. However, multiplication and division, as well as addition and subtraction, these two depend on the order. So it's actually multiplication and division, and then it's addition and subtraction. Both of these are the same depending on the order, so whichever one comes first. For example, if I had 6 minus 3 plus 2, because subtraction comes first here when going from left to right, I would do subtraction first. So I would do 3 plus 2, and then 3 plus 2 is 5. Now, in this case, if I have 5 plus 3 minus 7, I would do addition first because it comes first, right? So 5 plus 3 is 8, 8 minus 7 is 1. Now, let's try something a little harder. If I had 5 plus 3 divided by 2 times 3. So there are no parentheses, there are no exponents, so then I would go to multiplication and division. And as you can see, division comes before the multiplication here. So I would first do 3 divided by 2. So now I have 5 plus 3 over 2 times 3. And now I have multiplication. So now I do 3 over 2 times 3, which is 9 over 2. And then I would add the 5. So now let's go ahead and try to solve this problem. 7 minus 7 divided by 7 minus 7. So I first go to the start of the PEMDAS, check for parentheses. There are no parentheses. Then I go to the next one, exponents. There are no exponents. Then I check for multiplication and division. And as I see, there is division. 7 divided by 7. So now I have to do the division. 7 minus 7 divided by 7 is 1 minus 7. And now I check for multiplication and division again. There is none. So now I go down to addition and subtraction. And as I see, there is subtraction. 7 minus 1 and 1 minus 7. So I first do 7 minus 1, which is 6, minus 7. And 6 minus 7 is negative 1. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 12. Now the first thing I'm going to do is I'm going to take the log on both sides. So I have log 6 to the power of x is equal to log 12. Now, an important property of logarithms is that, let's say I have log a to the power of b. I can actually move this exponent b to the front of the logarithm. So this is going to be equal to b times log a. So now for log 6 to the power of x is equal to log 12. For log 6 to the power of x, we can think of a as 6 and b as x. So if we want to change it into the form b to the power of b times log a, I'm going to move this exponent x to the front of the logarithm. So now this will be equal to x times log 6 is equal to log 12. Now I can divide both sides by log 6. So then these two cancel out, and I would have x is equal to log 12 over log 6. Now, log 12, this is the same thing as log 6 times 2. And for logarithms, an important property is that if we have something in the form log a times b, this is equal to log a plus log b. And the same obviously applies vice versa. So for x is equal to log 6 times 2, log 6 times 2 would be equal to log 6 plus log 2. And we're dividing this by log 6. So now we can rewrite this as log 6, over log 6 plus log 2 over log 6. So for log 6 over log 6, those two cancel out, so that would equal 1 plus log 2 over log 6. Now, log 6, I can rewrite as log 2 times 3. And remember, if we have something in the form log a times b, this is equal to log a plus log b. So that we have x plus 1 plus log 2 over log 2 times 3. This would equal log 2 plus log 3. So I have log 2 plus log 3. Now, the value of log 2, if you plug this into a calculator, it is approximately 0.301. And the value of log 3, if you plug into a calculator, it is approximately 0.4771. So we have x equals 1 plus log 2, which is 0.301, over log 2 plus log 3. So 0.301 plus 0.4771. So now I have x is equal to 1 plus 0.301 over 0.301 plus 0.4771 is 0.7781. Now 0.301 over 0.7781 is 0.3868. And finally, 1 plus 0.3868 is 1.3868. So this is our answer. So we have 9 to the power of x is equal to 18. Now the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b. We can actually move this exponent b to the front of the logarithm. So this is going to actually equal b times log a. So I'm going to use this property on log 9 to the power of x. So we can think of 9 as a and x as b. So I'm going to move our x here to the front of the logarithm. So this is going to equal x times log a. So now I have x times log a is equal to, sorry, it's not a, it's 9. So I have x times log 9 is equal to log 18. Now we want to isolate x, obviously. So I'm going to go ahead and divide log 9 on both sides. So now I have x is equal to, because these two cancel out, log 18 over log 9. Now 18 is equal to 9 times 2. So I'm going to rewrite log 18 as log 9 times 2. And now we're dividing this by log 9. So now, if I have a logarithm in the form log a times b, this is actually equal to log a plus log b. Because remember, if you guys already didn't know, when you're adding logarithms, you're technically just multiplying the two numbers in front of the logarithms. So now log 9 times 2, this is going to equal log 9 plus log 2. So now I have log 9 plus log 2 divided by log 9. And now, this is the same thing as log 9 over log 9 plus log 2 over log 9. All I simply did was I divided this into two parts, because remember, if you add these again, you'll simply get log 9 plus log 2 over log 9. So now, log 9 over log 9, these two would cancel out, so this is the same thing as 1. So I have 1 plus log 2 over log 9. Now, log 9, well, 9 is the same thing as 3 squared. So now if I replace 3 squared for 9, I get x is equal to 1 plus log 2 over log 3 squared. Now remember, property of logarithms, that states that if we have something in the form log a to the power of b, we can move our exponent b to the front of the logarithm, so this would equal b times log a. So log 3 squared